All right, in today's video, we're looking at evaluating limits analytically. This is the second day of limits. Reviewing a few things that you know, or we learned on the first day. First thing is the form of a limit. Limit as x approaches c of f of x is equal to L, and L must be a finite number. If it's not finite, it's considered unbound, and that's one of our reasons a limit does not exist. Unbound behavior differs from left and right, and oscillation. So last time we looked at a bunch of graphs and things of how we do limits. Today we're looking at how we do them analytically, algebraically, a few different ways we would say it, but by hand working them out. There's going to be a few per page. I'm only going to do one per page just to show you the idea because this is just a video for you to kind of get a refresher. The first one is the simplest one, and this is what you should start with every time, is plug it in. All right, so first thing we're looking to do is plug it in. So, for example, first one, limit as x approaches 4, we're going to plug in 4. All right, 4 minus 4 squared is negative 12. There's our limit. That's it. Nothing too crazy. Each one of these has a similar process to that. Now, not always is plugging it in going to work. For example, if we tried to plug in 4 to the top one here, we'd end up with 0 over 0. So our next method we look at is factoring. Specifically, trying to factoring with the intent to cancel. So factoring with the intent to cancel something else. All right. Now, one thing you should know about this, these are not set steps in order. The only one that you should do in any set order is the first one, and that is plugging it in. After that, it should be whatever looks like is useful. This one has a bunch of an x squared minus 16 on top and then an x minus 4 on bottom. So factoring is going to be useful there because we can visually see that things might factor and cancel. So let's go ahead and factor. We have limit as x approaches 4 of x squared minus 16 factors into x minus 4 times x plus 4 all over x minus 4. Cancel the x minus 4s, boop, boop, and we're left with limit as x approaches 4 of x plus 4. At this point, it has canceled so that we can plug in 4. See here, if we look here, if we tried to plug in 4 before we cancel, we'd still get a 0 over 0 there. But now, if we plug in 4, we don't have any zeros in the denominator or any 0 over 0. So we end up with 4 plus 4, which is 8. Okay, so that's process 2. All right, moving on to process 3 is multiplying by the conjugate. So once again, we try and plug in 0 to x, end up with a 0 over 0 if we simplify it all down. So we're going to multiply by the conjugate. Now in this case, we can tell it's a conjugate because we have a square root in there. When you have a square root like that, usually you're wanting to get rid of the square root and multiply by something. This is one of the ones that requires a little bit of work to it. So let's see if I can move this one out of the way. We're going to multiply by the conjugate here. And when we multiply by the conjugate, we look at the part that has the square root, and we multiply by that same thing, but with a different or the opposite operation in between the square root and the constant. So multiply by square root x plus 1 plus 1, square root x plus 1 plus 1. Now I'm actually going to start with the bottom here, with the denominator, because that part's easy. It's x times square root x plus 1 plus 1. The numerator should also be easy if you know what we just did. By multiplying by the conjugate, we've created a difference of two squares. We have a minus b times a plus b, which means we know that this should simplify down to a squared, or the first term squared, so square root x plus 1 squared, which is just x plus 1, minus b squared. 1 squared is just 1. Now, we still cannot plug in 0. If we visually look at this and think if we plug in 0, we still have a 0 in the denominator there. So let's simplify. Limit as x approaches 0, plus 1 minus 1 will cancel, so x on top. X times square root x plus 1 plus 1. These x's will now cancel right here. They'll cancel out, and we're left with limit as x approaches 0 of 1 over square root x plus 1 plus 1. Now we're at a point where we can plug in 0. So we plug in the 0, 1 over 1 plus 1, 1 over 2. So there's our limit. So that's multiplying by the conjugate. Okay. Moving to the next one. Next one is getting the common denominator. Okay, least common denominator. So that's this top one here. Let me move this one out of the way because we will have to talk about this one in a second. There we go. All right, least common denominator. LCD. Once again, we have a situation where if we tried to plug in 0, we'd get 0 over 0 or 0 in the denominator, and we don't want that. So we're going to do the least common denominator, which means we're going to start with this part right here, the part that has the fractions. Easiest way to get the least common denominator is to multiply this denominator by this numerator and this denominator by this numerator, and then multiply the denominators together. Okay, so let's look at what that would look like. Limit as x approaches 0. 2 times 1 gives us 2. Minus 2 plus x times 1 gives us 2 plus x. Divided by, and then we multiply these two together. 2 plus x times 2, 2 plus x. Now, one thing to know about when we're doing these, whether it be conjugate, least common denominator, factoring, is you don't want to multiply anything out until you see what cancels, right? Because ideally, you want something to cancel. So you want to hold off and multiply things out to then. And then we still have all of this, because we only worked on this part right here, divided by x. Now we want to try and simplify it some, because if we plug in x, we still get a 0 on the denominator there. 2 minus 2 gives us 0. We have to remember to distribute the negative to that x there, so negative x over. This x can just move up to that denominator. If you don't know how to did that, ask me in class one day. But that x just moves up to the denominator, so 2x is 2 plus x. Now we have an x on top and an x on bottom that'll cancel. Oops. Approaches 0. Of negative 1 over 2 times 2 plus x. One of the big things that happens in these problems, whether it be least common denominator or conjugate, is people miss the negative. So keep an eye on your negatives as well. Equals negative 1 over 4. Okay? All right, now we're going to stay on this page. I'm just going to switch the problem around, and we're going to pull out number 9 there. Okay. Our next type of problem is one where you have to multiply it out. So multiply it out. All right, this is one where it's very rare cases, but you'll know it when you'll see it, because it's not going to have anything that can factor and cancel. There's no way to factor and cancel anything here. It's not going to have any denominators for least common denominator. It's not going to have any conjugates for multiply by the conjugate. And you can't be able to just plug it in. In this case, we're trying to plug into h, and we can't do that. So our only option is to multiply out this x plus h here and just cross our fingers and hope things cancel out for us. Hint, hint, they will. So we're going to multiply it out. Limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared over h. And now if we look what happens here, the x squared here and the x squared here will end up canceling. And we're left with an h in every term of the numerator and denominator. So h's can cancel. Limit as h approaches 0 of, don't need a denominator there, of 2x plus h. And we can now plug the 0 into h. And so we get this limit is equal to 2x. Okay? All right, so that's all the different methods we have for analytically solving limits. The next thing we're going to look at is trig limits. For the most part, these are going to be exactly the same as anything else. You'll plug them in if you can, and if not, you'll try and figure something out, except for one case. And that's this one right here. So I want you to graph this on your calculator. You should have one at home, and see what you see as x approaches 0. All right, so on your calculator, you should have seen something like this. Okay, something like that right there. Now, here's the issue. If we plug in 0 there, we can see for sure that it is not going to be a value. We can't plug in 0. Sine of 0 is 0, 0 on the denominator is 0. We can't use factoring and cancel because sine can't cancel. We can't use the conjugate because there's no square roots. We can't use least common denominator because there's no extra fraction here. We can't multiply it out because there's nothing to multiply out. This is one of the ones that you just have to know. The limit as x approaches 0 of sine of x over x, even though there's a hole there, is equal to 1. Now, there are a few things we can get from this as well. All right, so I want you to graph this one on your calculator as well. So we'll see it go much higher this time. Okay. So now when you look at it, you put in the calculator and you try and trace where that is, you'll notice that that's equal to 4. So what do you think this number right here does to helping us figure out what this limit is? That number determines it. So the limit as x approaches 0 of sine A of x over x is equal to 4. Or sorry, not 4, is equal to A. So whatever that number is will help. Now, we have a few other things we can garner from this. We can also say that the limit as x approaches 0 of sine ax over ax is equal to 1. All right, let's look at the next one. So now we have sine of 4x over 2x. I want you to graph this one. All right, so you should notice on your calculator when you graph this one that this is at 2. Now, is that saying that this denominator is the one that determines what it is? No, what's actually happening is the limit as x approaches 0 of sine 4x, or sorry, keep wanting to write the same problem down, sine ax over bx is equal to a over b. So really this equals 4 over 2, which simplifies down to 2. Now there are a few different ways you can work around this, and we'll look at in class how we can work some things that involve that. Yeah, that's it. So you'll have a great day.